All right, now we're going to do some function operations. All right, so, and I'm going to just jump right in because most of you have seen these before, and so let's just go ahead and start doing some examples. If I give you two functions, then this tells me how to add, subtract, multiply, and divide them. And for division, it tells me what the domain is. For all of these, the domain doesn't change except for division. So, part A says, what is f plus g of x? Well, f plus g of x is f of x plus g of x. And this is just a substitution game. So f of x is 2x minus 5 plus g of x is 2 minus x. So then that is x minus, I can only add terms that are alike, so I can add these two and I can add these two. Or I can combine the ones I've bracketed together. So minus 3. Part B is what is f minus g of x? Well, I like to write this as f of x minus bracket g of x. So that when we substitute the next step, when we say 2x minus 5, we don't forget to put the bracket in there. So now we remember that we have to distribute. So we have 2x minus 5 minus 2 plus x. So that we get, for our final answer, 3x minus 7. Part C, we have fg of x. Well, this means f of x times g of x. So that means 2x minus 5 times 2 minus x, which is, now I'm going to use distributive property. So that's 2 times 2x minus 5 minus x times 2x minus 5. So that's 4x minus 10 minus 2x squared plus 5x, which gives us minus 2x squared plus 9x minus 10. All right. Now for part D, this is where our domain changes, so we get f over g of x, which is f of x over g of x. So that's 2x minus 5 over 2 minus x. So, but we can't have 2 minus x cannot equal 0, so 2 cannot equal x. So this part of our domain changes in this one. Okay? My dog's about to go bonkers. Okay? So make sure that you realize that for part D, your domain changes because you are changing what your denominator is. Okay? All right, so now let's look at our next example, number 28. So, for part A, if I have f plus g of x, this will be x over x plus 1 plus x cubed. And when we add that, we need to get an LCD. So our LCD is x plus 1. So that's going to be x plus x cubed times x plus 1 over x plus 1, because they're both now over the same LCD. So what we get is x plus x to the 4th plus x cubed all over x plus 1. Our domain hasn't changed because we still had the domain here that x could not be negative 1. All right. For part B, we have f minus g of x, which is x over x plus 1 minus x cubed. Again, our LCD is x plus 1, so we have x minus x cubed times x plus 1 all over x plus 1. So this time we get x minus x to the fourth minus x cubed all over x plus 1. C, we have fg of x, which is x over x plus 1 times x cubed, which gives us x to the fourth over x plus 1, because this is over 1. And for D, we have f over g of x, which is f of x over g of x, which ends out being x over x plus 1 all over x cubed. Now I'm going to write this over 1, which is x over x plus 1 times 1 over x cubed, because we flip the denominator and multiply. So this x can cancel with this and leaves x squared. So what our new function is 1 over x squared times x plus 1. Our new domain is now all real numbers is the set of x such that x is a real number, but x is not equal to 0 or negative 1, because this puts in the fact that it can't be 0. If I write this in interval notation, the domain is negative infinity to negative 1 union negative 1 to 0 union 0 to infinity. All right, please let me know if you have any questions over this. I kind of went through this kind of quickly because when I've taught this class in the past, most students understand this. All right, please email me if you have any questions. Thank you.